We want to be able to pick up our collectible game objects when our player game object collides with them. To do this, we need to detect our collisions between the player game object and the pickup game objects. We will need to have these collisions trigger a new behavior, and we will need to test these collisions to make sure we're picking up the correct objects. The pickup objects, the player's UFO, and the walls all have colliders that inform us about collisions. If we didn't test our collisions to find out which objects we've collided with, we could collect the wrong objects by accident. We could collect the walls, for example. First, we need to reactivate our player, highlight the player game object, and click the active checkbox to make the player visible once more in the scene. Next, let's select the PlayerController script and open it for editing by double-clicking on the script name in the PlayerController component. Just a note, we could edit this script regardless of whether the game object is active or not. Now that we have the script open, what code are we going to write? We could write collider and then search the documentation using the hotkey combination. But there is a different way that we could do this as well. Let's return to Unity and look at the details of our player game object. What we're interested in here is the Circle Collider 2D component. In the header of each component on the left is the component's turn-down arrow, the icon, the Enable checkbox if it's available, and the type of component. On the right is the context-sensitive gear gizmo and an icon of a little book with a question mark. This is what we need. This is the quick link to the component reference in the Unity manual. If we select this icon, we are taken not to the scripting reference, but to the component reference in the Unity manual. We would read this document to find out more about how to use this component in the context of the editor. We, however, want to find out how to script to this component's class. To do this, we simply switch to scripting, and we are taken to the scripting reference for the Circle Collider 2D. We want to detect and test our collisions. For this project, we're going to use onTriggerEnter2D. You'll find this at the bottom of the documentation page under Messages. Just imagine if we were, say, a daring plumber, and we jumped up to collect a perfect arch of coins and bounced off the very first one as we collected it and fell back to the ground. Not very elegant. This code will give us the ability to detect the contact between our player game object and our pickup game objects without actually creating a physical collision. Click on onTriggerEnter2D to learn more. The code example on this page is not exactly what we're looking for, but that's okay. We can change it. First, let's copy a portion of this example code. We'll copy from the line public bool character in quicksand to the closing bracket of our onTriggerEnter2D function. Let's paste this beneath our fixed update function. Next, let's look at this code. We're using the function onTriggerEnter2D. onTriggerEnter2D will be called by Unity when our player game object first touches a 2D trigger collider. We're giving, as an argument, a reference to the 2D trigger collider that we have touched. This is the 2D collider called Other. This reference gives us a way to get a hold of the 2D colliders that we touch. With this code, when we touch another 2D trigger collider, we will set the Boolean variable character in quicksand to true. This won't change anything in our game, but could be used by another script to make the player move slowly, for example. For the sake of this lesson, we'll use this to do something different. Previously, we deactivated the player object manually in the editor when we were creating our pickup objects. Now, we will deactivate our pickup objects via script. First, we can remove the 2 lines containing the character in quicksand variable. Next, how will we deactivate our pickup objects? Well, what clues do we have? We can address the other collider's game object through other.gameObject. We want to test the other game object, and if it's a pickup object, we want to deactivate that game object. So let's look up game object with our hotkey combination and see what we can find. In the documentation page for game object, there are a few important items that we want. The first is tag. Tag allows us to identify the game object by comparing the tag value to a string. The second is setActive. This is how we activate or deactivate a game object through code. The last item we need to know about is compareTag. CompareTag allows us to efficiently compare the tag of any game object to a string value. Let's open up these 3 items, each in their own tab. Tag allows us to identify a game object by a tag value. We must declare our tags in the Tags and Layers panel before using them. Once the tag has been declared, we can use this tag in our code. In this example, the game object's tag is being set to player. To test, check, or compare a tag, there is an efficient built-in way, and that is compareTag. With compareTag, we can efficiently compare the tag of any game object with a string value. Let's copy the sample code and paste it into our working palette. Now, gameObject.setActive. This is how we activate or deactivate a game object. This is the code equivalent of clicking the active checkbox next to the name field in the inspector. In our case, just like the code snippet, we will call gameObject.setActiveFalse to deactivate our pickup game objects. Let's copy this code and, returning to our script editor, paste it into our palette as well. I feel we have enough pieces to write our code. Let's delete the game object that we previously typed, and let's modify the following line to read if other.gameObject.compareTag pickup. The pickup tag has already been defined in the project that you downloaded, but we'll take a look at how to add your own tag to the Tags and Layers panel. We can also delete the destroy other.gameObject line. We are going to add braces to our if statement. This code will work without braces. Without braces, however, only the next line of code is associated with the if statement. All remaining lines of code will be executed regardless of how the conditions in the if statement are met. To associate multiple lines of code with an if statement, they must be enclosed in braces. For clarity, in this case, we will enclose our gameObject.setActiveFalse line inside a set of braces, making sure that the code is properly indented. Remember, indenting code has no meaning to the compiler. Creating braces around our code now not only makes the association with the if statement clear, but will allow us to easily update this block of code in later lessons. With the script as it's currently written, we would be setting the player's game object to inactive. Instead, we want to deactivate the other game object. So let's change our second line to other.gameObject.setActiveFalse. Now, this code will be called every time we touch a 2D trigger collider. We're given a reference to the collider we touch. In Other, we test its tag, and if the tag is the same as the string value pickup, we will take the other game object and we will call setActive false, which will deactivate that game object. Let's save the script and return to Unity to check for errors. The first thing we need to do is to set the tag value for our pickup prefab. Navigate to the Prefabs folder and highlight the pickup prefab in the project window. With the pickup highlighted, click on the tag list at the top of the inspector. We'll see that the pickup tag has been predefined as part of the project. If we needed to define an additional tag, we could choose Add Tag. This opens the Tags and Layers panel. Here, we can hit the plus button to add a new tag to our list of tags. To delete a tag, highlight it and hit minus. Next, highlight the pickup prefab and let's assign the pickup tag to it using the tag menu. Select Pickup. Now, through the power of prefabs, if we highlight a pickup in the hierarchy, we'll see that it too has been tagged Pickup. Now, let's test our game. Save the scene and enter play mode. Okay, our tag is set to pickup, but we're still colliding with the pickup objects, just like we are with the walls. So let's exit play mode. Before we discuss why we are bouncing off the pickup objects rather than picking them up, we need to have a brief discussion about Unity's physics system. Let's look at one of our pickups and our player. As an aside, we can select 2 or more game objects at the same time and inspect them all. We do this by holding down the Command key on Mac or the Control key on Windows and selecting the game objects. When we select multiple objects, note how the inspector changes to show the common components and property values of the selected game objects. The inspector also allows for multi-object editing. Using multi-object editing, I'm going to disable the sprite renderer on both the player's UFO and the selected pickup with a single click. This leaves us with the 2 green outlines of the 2D collider areas for these 2 objects. So, how do collisions work in Unity's 2D physics engine? The 2D physics engine does not allow 2 2D collider areas to overlap. Remember how the player was ejected from the middle of the background sprite in our previous lesson. When the 2D physics engine detects that any 2 or more 2D colliders will overlap that frame, the 2D physics engine will look at the objects and analyze their speed, rotation, and shape and calculate a collision. One of the major factors in this calculation is whether the 2D colliders are static or dynamic. Static colliders are usually non-moving parts of our scene, like the walls, the floor, or other parts of the scenery. Dynamic colliders are things that move, like the player's UFO or a car. When calculating a collision, the static geometry will not be affected by the collision, but the dynamic objects will be. In our case, the player's UFO is dynamic or moving geometry, and it is bouncing off the static geometry of the pickups just as it bounces off the static geometry of the walls. However, the 2D physics engine can allow the penetration or overlap of 2D collider areas. When it does this, the 2D physics engine still calculates the 2D collider areas and keeps track of the collider overlap, but it doesn't physically act on the overlapping objects. It doesn't cause a collision. We do this by making our 2D colliders into triggers, or 2D trigger colliders. When we make our colliders into a trigger, we can detect the contact with that 2D trigger through the 2D onTrigger event messages. When a 2D collider is a trigger, we can do clever things like place a trigger in the middle of a doorway in, for example, an adventure game, and when the player enters the trigger, the minimap updates and a message plays, "You have discovered this room." Or, every time our player walks into an area, a sound plays because the player has walked through a trigger. For more information on 2D on-collision and 2D on-trigger messages, see the lessons linked below. We are using on-trigger enter 2D in our code rather than on-collision enter 2D. So we need to change our collider 2D areas into trigger areas. Let's select the prefab asset and look at the Circle Collider 2D component. I'm going to reactivate the two sprite renderers and highlight the pickup prefab. In the Circle Collider 2D component, we see a property called isTrigger. Let's set this to true. Now, let's enter play mode and test. Excellent. Let's exit play mode. So far, everything looks great, but we have one issue. We've made a small mistake, which is related to how Unity optimizes its 2D physics. When using 2D physics, all of the static or non-moving colliders are calculated as a single body. This increases performance. If we move a collider that the engine is not expecting to move, the static collider for all our non-moving objects will have to be recalculated. If we do this every frame, we risk our game losing performance. Where we've made our mistake is by rotating our pickups. We need to indicate to Unity which 2D colliders are dynamic before we move them. We do this by using the rigid body 2D component. Any game object with a 2D collider and a rigid body 2D is considered dynamic. Any game object with a 2D collider but no rigid body 2D is expected to be static. Currently, our pickup game objects have a circle collider but no rigid body 2D. So Unity is recreating the colliders for the pickups and walls each frame. The solution is to add a rigid body 2D to the pickup objects. Let's enter play mode and test. As we can see, our pickups fall off the screen. Gravity pulls them down, and because they are triggers, they don't collide with the walls. If we look at the rigid body 2D component, we see that we could simply set gravity scale to 0, which would prevent the pickups from falling downwards. This is only a partial solution, however. If we did this, even though our pickups would not respond to gravity, they would still respond to physics forces. There's a better solution. That is to select isKinematic. When we do this, we set this rigid body 2D component to be a kinematic 2D rigid body. A kinematic 2D rigid body will not react to physics forces and can be animated and moved by its transform. This is great for everything from objects with colliders like elevators and moving platforms to objects with triggers like our collectibles that need to be animated or moved by their transform. For more information on the rigid body 2D and isKinematic, see the lessons linked below. Let's save our scene and enter play mode to test. Now our behavior is identical and performant. So static 2D colliders shouldn't move, like walls and floors. Dynamic 2D colliders can move, but should have a rigid body 2D attached. Standard 2D rigid bodies like our player are moved using 2D physics forces. Kinematic 2D rigid bodies are moved using their transform. In the next assignment, we will count our collectible objects and make a simple UI to display our score and messages.